Hello, calculus fans. This is one of the limits that we talked about in the previous video. Let's now prove that it does not exist, as we conjectured. So let's let f of xy be equal to x squared minus y squared over x squared plus y squared. Remember, we're going to be choosing different paths to examine the limit, so let's approach 0, 0 along the x-axis. So approaching along the x-axis means we're going to pick y equals 0, and if we do that, then now f of x comma 0 will be equal to x squared over x squared, and that's just equal to 1, as long as x is not equal to 0, and we don't really care what happens at x equals 0. So that tells us that the function approaches 1 as xy approaches 0, 0 along the x-axis. Now let's approach along the y-axis. This time we'll put in x equals 0. When we do that, then we have f of 0y equals negative y squared over y squared, which is equal to negative 1, as long as y is not equal to 0, and we don't care what happens when y is equal to 0. So, f of xy will approach negative 1 as xy approaches 0, 0 along the y-axis. So what we've proven is that f has two different limits, approaching along two different paths. That means the limit does not exist. Let's look at a picture of the two different paths. Here we see the two different paths. In the red, approaching along the x-axis and getting a limit of 1, and in the blue, approaching along the y-axis and getting a limit of negative 1. Two different paths yielding different limits tells us that the limit does not exist. Okay, that's all for now.